The Amazon rainforest includes about 1/2 of the world's tropical forest and is a key component of the global water and carbon cycles. It is also one of the most biodiverse regions on Earth. Amazon tropical forests have experienced very severe droughts during the last 2 decades, with a frequency that may have exceeded natural climate variability. Severe droughts impact the physiological response of Amazon forests, decreasing their ability to absorb atmospheric CO2, as well as reducing biodiversity and increasing the risk of fires. Droughts in this region also affect animal populations by isolating them due to anomalous low river levels and increased mortality. The year 2023 has been recognized as the hottest year on record, surpassing the previous record established in 2016. Widespread warm temperature anomalies and extreme heat waves occurred during the second half of the year 2023 across South America. During this period, extremely warm and dry conditions hit the Amazon, leading to huge ecological and socioeconomic impacts. Remote sensing techniques provide a valuable tool to understand and assess the impacts of drought across vast regions such as the Amazon forest canopies. We used imagery acquired from Earth observation sensors on board satellites to analyze the changes in the vegetation status and thermal anomalies in the Amazon during the 2023 drought. Extremely high and anomalous temperatures were observed during the second half of 2023, during the austral winter and spring seasons. These record-breaking temperatures led to water stress and heat stress conditions over certain regions of Amazonia. Drought conditions also impacted vegetation health, with some regions showing a decline in vegetation greenness. Fire activity is linked to high temperatures, low relative humidity, and precipitation, which modulate vegetation stress and fuel levels. The climate, especially during extreme droughts, has been shown to exacerbate fire incidence, intensity, and severity in the Amazon forest. Drought impacts were still observed in the austral summer of 2024. This was as expected because of the intense El Niño event in 2023 and 2024, but the impacts were enhanced due to the severe drought conditions of 2023. The spatial overview provided in this study is particularly relevant considering that the southern part of the Amazon basin is already undergoing a biophysical transition, characterized by a lengthening dry season and increased tree mortality and fire activity. Our results confirm that during 2022 and 2023, water stress and significantly warm conditions were dominant during September, October, and November, which corresponds to the climatological dry to wet transition season in southern Amazonia. These results are in line with future projections for temperature and precipitation across southern Amazonia, where a warmer and delayed onset of the wet season is projected as a consequence of global climate change and deforestation.